Welcome to everybody, to current fellows and alumni. Here, Cristiano. So today we are happy to host Stefano Fiorucci. Stefano is a software engineer, passionate about machine learning in general, but in particular language models and open source development and knowledge sharing. He's very active on LinkedIn, and this is great. He was a fellow at session 10, if I'm not wrong, session 10 of High School of AI. Is now contributing to Haystack, which is an open source LLM orchestration framework at Deepset, which is a startup or already, let's say, a company in Berlin, in Germany. So Stefano will walk today us through some recent work he has done on Gemma 2 for the Italian language. And I think he will also introduce us to Spectrum, which is a memory-efficient fine-tuning method that allows selective updating of model weights and parameters. So I don't want to spoiler more. And welcome again, Stefano, and to everybody. And we can start our tech talk. Thank you.
Yeah, thank you, Christian. I'm happy to be there. Probably, Cristiano told what you may want to know about me.
So, you can also repeat it by yourself.
Yeah.
Maybe it's better.
I'm a software engineer, also passionate about NLP and LLMs. I like working and contributing to open source. And here you can find my GitHub account and my LinkedIn contact. And today we are going to talk about my recent work as a practitioner in fine-tuning Gemma for Italian. Here there are the steps I followed, but we will see them later. And here there is also this QR code for the Catgoal notebook. I will provide also the link in the chat, so you can. I will share my screen, but you can also follow the notebook. And I've made a copy of this notebook in Colab, and I will start from there. So Gemma is a family of open generative language models by Google that come in different sizes. One particular aspect about Gemma is that its vocabulary is very large, and it has been trained not only in English but in small fractions of other languages. So it is good. It is suitable to be fine-tuned in other languages without doing continued pre-training, but only with fine-tuning. And continued pre-training would be costly. So this is good. And we first start installing the libraries. I'm using the TRL, which is a framework by Hugging Face for fine-tuning. And we will also use the Hugging Face API for calling models, as we will see. But first, a question. Here I'm focusing on the 2 billion parameters model, so the smallest. Why can it be improved for Italian? There can be several reasons, including fluentness, but something I noticed is that sometimes you prompt the original model completely in Italian, but you get an English response. And this is something that we can fix among other things. To improve something, you generally need to measure its performance in some way. And so I chose to focus on the metrics provided used by the OpenITA LLM leaderboard, which is the most popular leaderboard for evaluating LLMs in Italian. And these metrics, they are two metrics based on multiple choice tasks. So ML, MEL, UIT, and ARCIT. And then LSWOC, which instead is a benchmark designed to evaluate common sense natural language inferences. And in this case, it's about sentence completion. And it's good to have these metrics to evaluate the model over time. But we will also do vibe checking and manual evaluation, because these metrics are not obviously comprehensive. So a basic overview of the steps we will follow. We will do post-training or fine-tuning. We will start from the already instructed version of Gemma. This is because it has interesting capabilities we want to use, we want to preserve, so it's not the base model. And we will perform supervised or instruction fine-tuning, and that data for this phase come in the form prompt and response. And we will also do preference tuning or preference optimization. In this case, the model learns from preferences, so it learns to choose and generate good responses over poor ones, and data for this step is in the form prompt, chosen response, and rejected response. So we can start with selecting data for this first step. In particular, I identified a good Italian dataset, which is Capybara Cloud Ita. Here, this dataset contains multi-tool dialogues, where the first prompt is translated from the popular Capybara dataset using Claude 3 Sonnet, and subsequent answers and instructions are generated with Claude 3 Opus. This dataset that I already used in the past is good, but it's not very big. So in the past, I succeeded in fine-tuning models for Italian with a small fraction of Italian data plus some English data. This can sometimes work, but it will be better if we have more Italian data. So I thought about translating a big data set, but also using LLM as a judge to ensure quality, because translating data for LLM training is not something that usually gives always good quality of data. So I started from this dataset, Find Tom by Maxime Labonne, which is a subset of a bigger dataset filtered for educational value and contains conversation, reasoning problems, and more. And I followed these steps. So I first extracted single-term conversation and performed the duplication. Then I translated the instruction. Then I evaluated the instruction using LLM as a judge. I removed the low-quality instruction. Then I translated the responses and evaluated the responses and filtered out low-quality responses. We will see these steps in more detail. I used for all these steps Llama 3.1 70B, which has good, strong capabilities in Italian. So the first step is about extracting single-turn conversation and deduplicating. I did this because I wanted to avoid too many API calls for translation, and also because the other dataset I already shows contained a lot of multi-turn conversation. So probably we can avoid having more of them. And we also performed the duplication because the original dataset contained the conversation that starts from the same starting point. So when you extract a single turn conversation, you have a lot of duplicates. And to do the duplication, I used the Minash, the duplication, very efficient. I practically almost copied the implementation by Distillable, a robust framework for synthetic data generation. And here is the code, which we can skip. And so I get this dataset to translate with single turn conversation. We can translate the instruction. To do this, I use the Llama 3 through the Hugging Face serverless inference API, which is nice because with the Pro account, which costs $9 per month, you get 20,000 requests per day. So if you are patient and on a budget, it's very good. Creating this dataset required several days and let's say weeks, but if you are on a budget, it's a good option. What's interesting in the translation is that I adopted structured outputs. So in this case, I want the translation inside the key traduzione, which means translation in Italian. And we can see some simple results. Here I translated the instruction using Llama 3, and I get the translated instruction. This approach is simple, but obviously to scale you need more engineering effort. You need to parallelize, avoid or minimize errors. And so in the companion GitHub repository, I also provided some code to do this at scale. So then we can evaluate the translated instruction using LLM as a judge. The idea is simple. We ask the language model to evaluate both the Italian fluentness and correctness of the translated instruction, but also whether the instruction is good or not. So if it's valid, if it does not contain the answer, if it is not truncated. And to do this, we adopt also this time a structured output, and we want a feedback, a short feedback, and a quality score, which can be low, medium, or high. An important thing to notice here is that making the model providing the feedback before the quality score, even the autoregressive nature of the model, makes the score more grounded. So this is a common approach. We can see some results. In this case, we get a high quality instruction with feedback and the score. In this other case, we have a medium quality instruction. Then we simply filter out low quality instruction, and then it's time to translate the responses, which is done using the same function as before. Okay. We can finally evaluate the translated responses using LLM as a judge. Also in this case, we want to evaluate both the Italian correctness of the translated response, but also how much the response is aligned with the instruction. And to do this, we adapt the ultra feedback prompt. And so, we explain to the model all these criteria, and we also ask for a feedback and the quality score. We can see some results. In this case, the response quality is 4, so good quality. In this other case, we can see that the response begins, in a good way, but unfortunately, it is truncated. And so, in this case, we get a low response quality, and this will be removed. And so, the final step is removing low quality responses. And here you can see the final data set generated, which is on Hugging Face. And now it's time to start thinking about training the model with this data. I did the training steps on an NVIDIA A6000 with 48 gigabytes of RAM. And the first step is data preparation, which is simple. Since Gemma does not support system messages, we decided to include the system instruction in the user message. I also tried removing it, but the performance works. And I also prepare the format. I format the conversation as a single text. We can see the result here. It is a single text that contains, for example, all special tokens, begin of string token, start of turn. So it's good. Something interesting to say is about max sequence length. We want to choose longer examples will be truncated. So we want to choose a max sequence length that tries to not to lose too much information, but also not waste GPU resources. And so if we set max sequence length to this value, we can see that we truncate only 8% of our example, which is good. Now, before training, it's time to introduce Spectrum. In this section, when I mention layers, I refer to lower level layers. So, for example, model layers 0 MLP down projection, not higher level layers. But apart from that, what we want to do is to train the model with less GPU than full fine-tuning. And a very popular way to do this is Cullora, which quantizes the original models and train adapters on top of it. And it has good result and is very popular, but has some limitations. It's in general inferior to full fine-tuning in terms of performance. You have to choose carefully the hyperparameters like rank and alpha, because they have high impact on the result. And then, as highlighted in a recent paper, it seems that applying LoRa and Cullora introduce intruder dimensions that are absent in the pre-trained model, and this can make the learning from the model less robust, and can also make the model go far away from the pre-training distribution and being less capable of adapting to new tasks. So I looked for alternatives, and I found Spectrum. The idea behind the Spectrum is that it analyzes the weight matrices for all layers and calculates a signal-to-noise ratio for each layer. And it mathematically is based on random matrix theory. And so you choose a percentage, and then Spectrum selects the most informative layers based on this signal-to-noise ratio of each type of layer. What you then can do is that you decide to freeze the whole model and just unfreeze the layers or parameters selected by Spectrum, and so you can focus your training on them. And in the original Spectrum papers, there are also some comparisons with Cullora, and we see that in terms of performance, Spectrum generally beats Cullora. In terms of memory efficiency in a single GPU, Cullora uses less memory, while Spectrum is better in distributed training. And there are also several good models trained with the Spectrum. And one interesting aspect that I discovered discussing with one of the authors is that Spectrum also helps preventing catastrophic forgetting. So the fact that when you train the model to learn new stuff, it forgets previous training. And we will see later in our training that I also have verified this in my experiment. So to identify layers to train with Spectrum, here is the code, but what we get at the end is a YAML file, which is truncated here with unfrozen parameters. So to use this with transformers and TRL, we have to load the original model and then simply freeze all parameters of the model and unfreeze just those identified by spectrum. And now we can finally train the model using the supervised fine-tuning trainer of TRL. Here there are several configurations that I'm explaining in the notebook. Something to notice is the learning rate, which is pretty low. I also tried the higher learning rates, but this would deteriorate the model. And the reason is probably that this model already underwent supervised fine-tuning, and so the learning rate is a bit lower than the usual values when you train from a base model. Here I'm also providing some tips to reduce GPU usage, but there is also a link to an interesting hacking phase page. So if you have a smaller device, you can try to apply these techniques. The loss curve looks good. We can then evaluate our model on benchmarks using LM evaluation harness. And from this supervised fine-tuning, we improved on all metrics for the Italian language. But now it's time to focus on preference optimization. The idea here is to learn from human or AI preference data. This idea was popularized by InstructGPT models from OpenAI. They used reinforcement learning with from human feedback. And in their case, they first trained the reward models based on human preferences, and then they used the proximal policy optimization to align the supervised fine-tuning model with the reward model. They achieved great results, but unfortunately, PPO is difficult technically, is complex, and requires much GPU. So a simpler technique that got popular is direct preference optimization, where instead of training a separate reward model, you directly optimize the SFT model using preference data. And DPO has gained significant traction, and it was also used by Meta in Llama 3. So it's a good technique. Also here we have to select some data, and I identified some small good Italian datasets, and then another Italian dataset which is bigger but comes with a limitation. In this case, they translated prompt from a Vol struct and generated the responses with two different models, GPT 3.5 Turbo and Claude 3 Opus, but they made an approximation. So the response from the better model is always chosen, and the other is always rejected. This is a common practice, but we can improve on this aspect, and we will see in a moment. But for this step, I also decided to include some high-quality English data to preserve English capabilities of Gemma. And in the notebook, I'm also providing some tips to find or create preference data in your language. So I decided for this big Italian dataset to re-rank the responses and to remove the approximation. And I did this using LLM as a judge. I used also in this case Llama 3.170B. And this is practically very similar to the previous application of LLM as a judge. The difference is that here we are evaluating two responses at the same time and not only one. And so I simply performed this step, and I got a new dataset, evolve DPO eta re-ranked. I now want to introduce a bonus step, which is about generating on-policy data. There are several papers that compare DPO with PPO, and most of them find that DPO is efficient but inferior in performance to PPO. And one of the main limitations of how DPO is often conducted is that it uses off-policy data. So data generated or by humans or by other models than the model being trained. And this can introduce a distribution shift and potentially affects performance. But this is not something inherent in DPO. It's just a common practice. So we can do something to fix this aspect. And also the recent 2-3 technical report showed that introducing on-policy data plus off-policy data can improve the model in terms of benchmark performance. And we can also generate this on-policy data offline. So I adopted a very simple approach that can be summarized here. The idea is to select some prompts, have your fine-tuned model produce the different sampled responses, and then use a reward model or a LLM as a judge to rank these two responses, and then you get your on-policy preference dataset. And I did this. I first selected a sort of prompt in my target language. In particular, I found this prompt in a dataset by Sapienza NLP. These prompts are divided into different task categories, and I decided to choose some of these samples stratified by task category. And so this is the first step, and I get some prompts. Now I can sample the model to generate different responses. And to do this in a quick and efficient way, I used the VLLM, and I did this on Kaggle GPU, so free GPU. Here the most important part is sampling parameters. You want to choose these sampling parameters to create responses that are quite different among them, but they should also not be completely random. So I did some tests, and for my case, these sampling parameters provide a good trade-off. And so, in this case, you get response 1 and response 2 to the same prompt. And then you can evaluate and rank them using LLM as a judge. In this case, I used Llama 3.3, which was released during my experiments and is better than the previous version. In the end, you get your prompt, and you get a chosen response and a rejected response. Then another optional thing I did, which diverges a bit from this idea of on-policy data, is that in some cases, in 3.5% of my cases, I noticed that the judge model judged insufficient both the two responses. So this probably points to some knowledge gaps of my small model. And so for this small number of cases, I decided to include a response from a strong model to try to fill these gaps. This is a very simple step. And in the end, we get this dataset. We can now train the model with direct preference optimization. this data preparation part is not very interesting. We are only adapting all data sets to the same format. Okay. And no, something that it's interesting here is that usually DPO, as reported in several papers, tends to produce long and verbose answer. And I wanted to fight this tendency. So I thought about, in case of ties between two responses, to select the shorter response and see if it works. So we can go to, also in this case, I want to choose max prompt length and max length, which are very similar to the previous choice about max sequence length. So it's a trade-off about not losing information and not wasting GPU. So I select some suitable values using a simple percentile approach. And then I load the supervised fine-tuning model. I applied the spectrum selection, and I can finally configure the direct preference optimization trainer of TRL, which some parameters which are explained here, and I train. And looking at the training plots, we can see that over time our models learns to prepare and generate good responses, or the chosen response over the rejected response. So apparently it was trained well. For inference, I provided an Hugging Face space. We can see if it works. For example, here I'm asking for a list of max 2 pro and cons of living in Italy. Let's see. In the pros, there is culture and climate. In the cons, bureaucracy and low salaries. This time probably it worked well. Okay, I'm also providing some steps to do inference with transformers, which we can skip. You can also do inference with, I'm also providing GGUF quantized versions of this model, so you can use this on Llama CPP or on Llama. And in the past, I experimented with running a very small and simple model like this on my cheap smartphone, and it works. It's time to conduct another evaluation. Let's see first the benchmarks. In this case, the average improved again, but I also wanted to do a more qualitative and vibe checking evaluation, which I did through these two Hugging Face spaces with the original model and my model. Across different areas of expertise. For example, we can see an example about data analysis. But what's more interesting, probably, if you look at the role-playing example, in this case, it talks about a spatial mission and stuff, but the prompt is entirely in Italian, and the original model, in this case, answered in English, while our fine-tuned model answered in Italian. Something also nice to notice is about safety. So I'm asking about cooking methamphetamine, and both the original model and our fine-tuned model, they refuse to answer. And this is interesting because I haven't provided any safety data. And so probably in terms of safety, the model was not deteriorated by our training. We can also see that it retained English capabilities. And another interesting aspect is that in general, I noticed that the average length of responses by my fine-tuned model is slightly shorter than the original model. So this probably suggests that our DPO strategy of selecting the shorter response in case of ties worked. Then, I'm also giving a very short example of a web RAG application you can build for with this model, because this model is small, has limited word knowledge. So, it's appropriate for RAG. I'm using Haystack, the framework I work on it. And in this case, I do web RAG. This means you first perform a web search and then include the retrieved information in the context of the language model to ground the answers. And this is the schematic view of our pipeline. And we can, for example, try with a very interesting Italian question. So, is carbonara made with or without cream? And using this web rack in Italian, we get the response that carbonara is made without cream. And we also get references. It is nice. And to end this presentation, I can say that even if this works for Italian, I hope this can also serve as an inspiration for similar efforts in other languages, also with other models. I haven't tried other languages. I only tried with a bigger version of Gemma. In particular, I started from a German fine-tuned model, which has good Italian performance. And using only DPO, I managed to improve this already strong model. And so, it is also evaluated on the OpenETA LLM leaderboard. And it seems a good model. Here in the notebook, I'm also providing the most important reference of this work. And I'm happy to ask some of your questions.
Wow. Thank you, Stefan. I'm sure that somebody will ask you the notebook somehow. I don't know if you can share it with us later, but anyway, I open the question session. Guys, if you have any question, curiosity regarding the talk, but also regarding maybe Deepset or more generally speaking, what it's the daily activities of Stefano working as an engineer in LLMs, feel free to ask him. Okay.
One question actually. I mean, not question, but I want to know if I understood correctly. Like usually when I am doing fine tuning, we usually define which layers to freeze, and mostly we would freeze the last layers. Using the spectrum, it can mathematically define which, using the SNR you said, can suggest us which test layers to freeze or keep active, right?
But these are divided by type of layer. So based on the specific type of layer, you get a percentage of them. For example, give me a moment, maybe I can share again my screen. If I can find the YAML. Yep. Oh, okay. Probably it was where it was. In general, maybe here is better. They are divided by types and then a certain percentage of each type. So you focus on lower level layers. It's not that you decide, we only train model layers for, but several layers distributed for type in the whole model. Something like this. Yeah. I answered your question.
Yes.
Go on.
Yes, thank you. Other question. You mentioned that you used LLM. You mentioned that you generated a data set. I think it was to create whatever the instructions that you had, and you wanted to translate it in another language. So for that, you generated the data set and asked the model to say what quality it is, low, medium, high. And I want to understand, like, how many instructions were there? Was it like different instruction for each of the record, or like in the end you just wanted one instruction and you just like, how many records were there? How many instructions were there? Did you have?
I basically asked the model for one instruction at the time. And for this reason, it required several days to perform this operation. And yeah, as I said, I used the Hugging Face Inference Pro because it's very, very cheap. But yeah, if you use another provider, you have to pay more, but it can be very faster because in this case, I parallelized the tasks. I was sending, I think, 12 requests at the time, but you get, the service is nice, but you have some limitation if you want to spend not much money. But I hope I understood. I'm passing just in my prompt, I'm passing one instruction to evaluate at the time. And so for the response, and when I perform LLM as a judge to judge two different responses, and one should be chosen and the other rejected. In this case, I'm passing two responses, but each record at the time.
Okay. And last question. You were explaining us the DPO, and that in DPO we retrain the SFT model that we have. And for the data set, you mentioned two things, like one that you found online, the preference data set, and another that you generated with the LLM. So, like, which model was that that you used to generate the synthetic preference data set?
Yeah, I used the model coming from the supervised fine-tuning. And also, I think also in this Tulu 3 technical report, you generally use the model coming from the SFT step. Then, to be honest, big research labs who apply DPO, like Meta for Llama, they do several steps. So you do SFT, then you do DPO, then you redo SFT, but this requires budget. I don't know.
I understood. Thank you so much.
Okay, thank you, Stefano. I think for the questions. Is anybody else? So, I have a question, but is more general. Given your experience in large language model, in open source development, and you see, what do you think about what's happening around? Recent advancement in think about DeepSeek and open source model versus American companies like OpenAI and Claude. I didn't finish yet. I haven't finished yet, but there is also a post by Dario Amodei from Anthropic that was discussed last week. Sorry, was discussing last week about this topic, and I pretty agree with many things of Dario, but I haven't finished last post from him, so I cannot say anything about it. But overall, what do you think? What's your impression? What do you think in the next year will happen?
Very
It's a difficult question, but anyway,
let's try.
Open a bit the discussion.
I am in general a fan of open source, but and also open models. In general, I also appreciated what some labs, big labs, did in the past. For example, OpenAI in the past, maybe they didn't share much, but at least their papers were good, and they gave people tools to produce similar models. What was great about DeepSeek is that they published everything, and you don't know how OpenAI did their reasoning models. So I like also, I recognize that also big labs, they try to protect what they create, but it's also nice if they can share at least the methods, the processes, and then I don't have any strong opinions about protecting this stuff. I don't know, but I also was impressed about all the hype around DeepSeek because, technically it was impressive, but there's something that I don't understand, but it's also very interesting, not about language model, but about mass psychology and how markets move. It's very interesting, but I can't find.
It's crazy. Last week, Italian television, but also Donald Trump, so the United States president, mentioned DeepSeek. I also heard at one very popular Italian TV journal that they were mentioning reinforcement learning, and was the very first time in my life that I heard in a popular program the term reinforcement learning. So it really was this kind of terminology is getting relevant. And okay, thank you. And instead, what are, in your opinion, the most interesting, maybe 1, 2, or 3 trends in large language model, or even libraries that you feel, okay, this is something cool, I need to have a look at it. So think about the 3 things you saw in the last months on LinkedIn, on Twitter, or in some paper that you saved somehow and told to yourself, okay, next weekend maybe I'm gonna study this stuff, or maybe I don't know, in the coming weeks I want to spend some time reading what this is about.
It's another difficult question, and obviously to answer GRPO would be too easier, even if I saw very nice experiments from people. For example, an experiment, since in this case you provide a reward function, which can be simple and deterministic. I saw an experiment when this guy takes a base model and make it produce poetry, only using 2 rules about not producing repetitions and having a verse structure, which is very nice. I'm very interested in this kind of training. And then something that it's not new, but probably it probably will come again in the future is model merging. So the idea of taking 2 different models and putting them combining their weights in some way without using a GPU. And there are also some recent new techniques merged in Merge Kit yesterday. And yeah, there is something I want to experiment with. This probably. And everybody is talking about agents. I don't know. I experiment with them, but I don't have the specific things.